question 4. So for part 1, well, let's start off by considering the momentum before the collision. So momentum of mass times velocity, so 0.2 times 4 together with 0.3 times 2. But be careful, this velocity is in the opposite direction. So if we make left to right positive, this right to left needs to be negative. So if we equate these two, we get a positive momentum of 0.2. So that is a net momentum left to right of 0.2. Now the key point you need to put into your answer is that we have conservation of momentum. So after the collision, we still have a positive momentum left to right of 0.2. Now regardless of what happens to P could go either way. For the net effect to be positive left to right, Q must go right, and P can't overtake Q, so Q has to go to the right, and then P may or may not go to the right or the left, but Q absolutely has to go to the right, because if Q is going to the left, P also has to go to the left, which obviously is giving us negative momentum. So you need to summarize that. So the key points to make is we've got a momentum before the collision of positive 0.2, so there must be a change in direction of Q because of conservation of momentum. Now for part 2, this takes a little bit of getting our mind around. Okay, now we know our momentum before the collision is 0.2, so let's consider after the collision. Now it may be that P and Q are both going left to right. Okay, so our two velocities are going in the same direction. We know the speeds are the same, so the numerical value is always going to be the same, but let's just consider that they're both positive. So we've got 0.2 v mass times velocity plus 0.3 v. So altogether that's obviously 0.5 lots of v, so v equals 0.2 over 0.5, which is 0.4. However, the consistency of these balls, the sponginess of them or what have you, may be such that in fact Q does go off to the right, but P actually goes off to the left instead. You know, it might be very springy, and so rather than following along behind Q, it actually just shoots off back the other direction. The speeds are the same, so its negative value for V is going to equal the positive value of V for Q. The question tells us that the speeds are equal. It doesn't tell us that the directions has to be equal. That's how we get our two values. So assuming P shoots off to the left, we've got mass times minus V plus Q mass times positive V. So minus 0.2 V plus 0.3 V is a net effect of 0.1 V. So V is 0.2 over 0.1, which is 2 meters per second.